Okay.
All right, so we
can start our
let's share our screen.
Introduction.
Yeah, you probably should be able, or you should be able to see our screen right now. And since our talk is packed of a lot of information, we're likely to start the very first bit of welcoming everyone to this presentation about Loom and Reactive. That's basically the question that we're going to be talking about. And yeah, we almost there. So let me first quickly introduce myself. My name is Oleh. I'm also so-called reactive person, since I'm always talking about reactive programming, reactive streams, and I work for VMware, and I work for I'm working at or in Project Reactive team. So I'm part of this great reactive effort, and a part of that I'm leading the RSocket effort as well. So if you want to learn about Reactor or RSocket, just come to me, come to my Twitter, and I'm going to help you. Well, today with me is expert of Loom, Andrew, who knows almost everything about Loom.
Not almost, maybe Ron Pressler, I think.
Of course, the person who develops Loom knows more. But
much more.
This person just checked out the JDK sources and checking every day what's going on with Loom. So probably he knows a lot about Loom as well, and he almost on the same level, but slightly lower than Ron Pressler.
Slightly behind the Loom authors.
Yeah, of course, but you are on the edge, let's say. And before we're going to start, we want to say a few things. That in this talk we won't be talking about Loom internals too much, because this has already been taught by Alan Batman. This is another committer to JDK to Project Loom, and he has a great presentation about Project Loom, more scalable concurrency for Java platform. As well as we won't be talking about Project Reactor reimplementation for Loom Super, because this is not the topic, and Project Reactor likely won't be changing dramatically. And if you want to learn more about internals of Project Reactor, I have already done that in Russian, in Ukrainian, in English. So welcome to see this presentation, or Google for similar one somewhere. So in order to explain why the Loom is a friend or foe of reactive streams, we decided to use a simple application, or real scenario where you start building something and you want to choose a technology. So based on this simple application, which doing networking to multiple destinations, you're gonna understand whether Loom is friend or foe, whether reactive is good, and whether reactive is going to be killed by Loom or not. So today we're going to be talking about IoT, and we want to build a simple application, like mobile application, server, and we want to build a set of sensors. So technically we won't be building sensors, since we're going to assume that sensors are installed at homes, but we want to build a system that collects info from sensors and then let you kind of monitor that from your mobile phone. So we have this simple UI. You are able to choose your apartment, since you're software engineer, so you may have multiple of them, right? And once you've chosen one, you want to observe the kind of the content, the temperature in your apartment. So before we get to the temperature, first of all, you may wonder how we can get to that point, or what's going on behind the scene on our server. So behind the scene, we have a simple server, a simple database, and of course, all the information about users are stored inside this database. And Andrew implemented this simple piece of code in order to communicate from your server to your database and kind of collect the information about this apartment and sensors inside this apartment. And of course, since user may be associated with multiple houses, there is a couple of steps. in order to retrieve this info from the database, like going for houses repository and then going for sensors repository. I apologize.
So we have here two methods that is going to the database house repository find by user ID. And when we have all our houses, we can select all sensors that are available in our particular house. So we can see house repository with find by ID and sensor repository find by ID. And this is blocking calls because we are going to the DB. Let's keep it in your mind.
Yeah, but in any case, it's simple. It looks really straightforward, and there is nothing complex in it at all. So even I, reactive person, agree with that. Anyways, this is not the main challenge here, since our main challenge is to collect temperatures. And in order to collect temperatures, of course, we have to go through the network to our sensors and collect this information. And the implementation, of course, in order to collect this info, we have to have like a client or API for accessing this information through some interface, which may look like this. And Andrew implemented our core logic at the first steps as this.
Let's start with this simple core logic. So what we should do here, we have all our sensor infos for the particular house, and to get the temperature for this house, we should go one by one to each sensor, we using sensor client, and get in our loop the temperature, and then start in some array, and then can return this array to the customer or to the web part.
Yeah, but it's clear that like even like engineers, normal engineers who are doing everyday development, or even junior engineers, just notice that this piece of code is absolutely inefficient, since we have to do like multiple calls, like basically n calls, since if we have n sensors, we have to do n calls plus one. So the response time of such engine or such algorithm is pretty low. So likely we want to improve this and do
in parallel.
Yeah, calls in parallel. So how you can implement
how we can do it? You can use our executor services for this, and for executor services we have method invoke call where we can pass some callables. Callables is another story how it's constructed, but it is very nice solution. We can invoke call and get the list of futures of sensor data where will be stored our temperature. And then going also by the loop, we can call the future get and put this data to the array.
Wait, I have a question about invoke call. So looking at the animation, it looks like that invoke all is blocking call, and when it's in block, we have already collected the data. So why list of futures? Does it make any sense, or is it work in a different way?
No, you are particular right. The invoke call, it's strange, but it works as you have described. It is the blocking call, and you should wait where will be list of futures will be filled by the data. And in this kind of the code, the future get will be non-blocking.
Well, this is weird. But anyways, there is another problem so far. Imagine that one of our services starts being slow, and for example, while the others respond in time, the other may take slightly long or more time. So this approach just makes no sense, since we would have to wait for the latest one.
No problem at all. Invoke call has a particular implementation where we can pass the timeout for the sensor, and we will not wait all our sensors.
Andrew, nobody does it like this. First of all, because imagine that between invoke call and like getting the results from the future, we may want to get, or we may want to do other operations like logging, or we may just want to do other work on the same thread, on the caller thread. And having this design, we basically blocked at invoke all, and we have to wait, and we cannot do anything else.
So we can re-implement it. Java util concurrent has another good methods. For example, the countdown lodge and executor service, where we can only submit our particular code, and it will be run in a separated thread. And we could write our implementation using the countdown lodge for this. And here it will be the same logic, and the timeout also will be played here, and you shouldn't wait all of your sensors.
Okay, right. It looks better, even though it looks kind of much more complicated than the previous implementation. But apart of that, are you sure that the shutdown now is gonna cancel this
Yes,
invocation?
trust me, I have checked this.
Well, are you sure that all the vendors of HTTP clients implemented? If you're talking about thread interrupt, are you sure that all of them has implemented this mechanic correctly?
Our task is Java specification. The vendors should follow this specification. Of course.
All the vendors should follow. That's what we do every day. Follow the specification. Anyways, another big problem is that if we're gonna start scaling and bringing more and more users to our platform, we're gonna get a scalability problem. And we all know that all this laws, like universal scalability law, MDL law, just talks that threads doesn't scale very well when we start increasing threads on the same or fixed numbers of CPUs, because there is concurrency, there is serialization points, and so forth and so on, and our scalability starts decreasing. So
let's move to the reactive async. And for the Java platform, we have the best implementation of reactive framework. It is Completable Future, of course.
Well, Completable Future. I know your Completable Future. I tried to implement. So the story starts that I tried to implement this logic first on Completable Future, and just the logic related to parallelization looked like this. This. And yeah, for me, it's reduction framework. I'm creating a seed Completable Future with a collection of possible data, and then I'm starting reducing elements. And well, it on the one hand simple for me, but for Andrew it's a rocket science. So likely he won't accept this solution.
No, I don't want to even see this because it is something crazy. I couldn't see my production business logic here. Only see complete, then apply, then combine, and similar other stuff. Especially with reduction framework, it is absolutely mess here.
I agree with him. This is the first time I'm saying that this piece of code is just simple and insane. And it's written in JDK 9, actually. You see here, complete on timeout. I added timeout, similar to what we had in imperative implementation. But the problem here that I found is that complete on timeout is absent in JDK 8 at all. So if you want to use JDK 8, you would have to write something similar on your own. Another problem, no cancellation. If in thread model, interrupt was kind of something that one may expect, in this model, even thread.interrupt is something that you may not expect. And if you rely on future.cancel, then, well, it may work or it may not work at all. So reliability of this piece of code is absolutely strange. And even though it works in very, very, very strange way. But
okay, what your proposition for how we can do it more simpler?
We may use a framework, external library, and I have one. This is Project Reactor.
Of course.
Project Reactor from Great Reactive Stream Story. So
okay. Let's show me how it looks like with reactive.
Absolutely. So Project Reactor have two reactive types: flux for a stream of events, and mono for a single event. And for our sensor client, we may just use mono since we want to make a request and get a response. So this is a stream of a single element, and this is mono. And what we can do, we can rewrite our logic, and for example, list user houses sensors may look much more simpler than with Completable Futures. Yeah, we haven't seen the Completable Future implementation, but this is just the first bit. And here we call find by user ID, and this method should return flux of house info.
Stop. From where flux of house info should appear?
Well, it should be supported by the reactive driver, like RDBC or Spring has reactive repositories. So I expect that we have integration with such.
Okay, you are lucky if you have.
Indeed. This is kind of the downside of reactive approach. So if we don't have a reactive API, then we would have to be slashed, or we would have to hack the API or wrap the API with kind of mono or flux and execute some blocking calls on another scheduler, which is similar to what we've seen before with threading model, and under the hood we're going to have cached thread pool. And I agree that this won't scale, but we rely on non-blocking API. Let's hope that in that scenario.
Okay, let's hope.
And for other users, and our users going to have reactive API as well. So here we get Flux, and then you have a ton of great methods on the Flux.
150 or even more.
This is the power of this tool,
Yeah.
and don't blame it. Just say that it's great, because there is a lot of things that can help you solving your problems. Anyways, we have filter, and filter is a great replacement for if in your for loop. Just strive forward. You understand that you're filtering your events, and then you have switch if empty, so nothing is found. Well, switch if empty, since your stream is empty, and you can just set an error. Simple. And then you have concate map, and you be able, once house is found, you may switch it or kind of transform it into another async call and merge it into your mainstream using concate map. Great. Simple. Even more. One more thing that I missed. I have to kind of rework all the API and replace all
re-implement all your code.
Indeed, that's true. I have to refactor all my API in order to support fluxes and monos in all the stack. Otherwise, it makes less sense, since other interactions going to be blocking. Anyways, look at this great implementation of merging requests from multiple sensors in parallel. Andrew, this is easy.
Are you sure that map here runs request in parallel?
Absolutely, because flatmap allows me to send multiple non-blocking requests concurrently, so I can merge them once they come in. Moreover, transformation is as easy as pie, so just map operator, and in order to time out the interaction or the call, I'm just saying timeout. And there is much more to this operator. There is retries. There is other type of operators that make sure that my communication is resilient and just awesome from the reader point of view.
Yes, it looks very simple, but what about the learning curve of this? For example, Completable Future has, I think, 50 or 60 methods, and Project Reactor 150 or 60. And it is very hard to catch all of them, catch the difference, and so on, especially for the beginners who's working with Project Reactor. It is very hard to write the right code in the right way. Will be,
I'm doing that for many years, and I'm fine.
Yeah, you're fine. But what about another people in your team? They should be also the same as you. The quality of their code should be the same. And one more, what about the debugging of functional reactive code?
Yeah, that's a problem.
If you will see some stack trace, you will not see here your business logic. Here will be only some flux, iterable, publisher, reactor, and so on. What about this?
Okay. You're saying true. That's absolutely true. Reactive is complex, but there is no alternative. So what do you want?
I want the most simple solution, and the most simple solution, as Brian Götz says, should be the Project Loom. The Project Loom should allow us to write code in the imperative way without any problems. By the way, also, he said something about the Project Reactor.
Really?
I think Loom is going to kill reactive program. Loom is going to kill reactive program. Kill reactive program.
Kill
reactive.
Oh no, that's not a good news, actually.
What you should say for this?
Well, let's see how your imperative Loom gonna help solving this type of problems.
And it will be very easy. On the first step, we shouldn't change our public API and our blocking implementation of our code. So we can continue to use our sensor blocking client with simple double return type.
Okay, but what about this?
And here we can change here only the one string of the code. We should change only the implementation of the executor service. So now it will be a new virtual thread executor, and nothing else should be changed here.
But wait! Don't lie to our audience. Since we have a blocking call here, and okay, this submit calls are running in the virtual thread, but this one and this one, which has two calls to blocking calls to database, where are they running on?
And this is not the problem, because we are running this code not in the some universe, not the from our main method. We are running this in the application server on the web server. And for the web server, for example, for JT, we have already some Loom preview features, and we can try running our usual Spring Boot application using JT with Loom. So we have
show me.
Yeah. We have conduct some experiments and put the breakpoint of the large await, and you can see the stack trace here, and you can see that the current thread is virtual, and you can see the stack trace that shows you that it will be all running in the virtual threads. So all blocking calls, particularly the large and request to the database, also will be run in a virtual thread. So we will be not blocking here at all.
Not bad. But I have another but in your speech. This code is still a piece of rainbow.
Oh.
Yeah. How Loom helps improving the code quality, because it's still not readable. Do you see, my friend? Where is the business logic? Okay, not behind this piece of rainbow, but here. Do you see the business logic here?
Yeah.
I see copy and write arrays, calm down large executor service, but business logic is just hidden by reactive.
So don't blame this code. We have we can use our invoke all, but now we can run it in virtual threads, and we will have no problems with blocking the results of the invoke call.
Okay, nevertheless, you are just transformed your invoke call into stream and use functional but JDK-based stream API in order to make transformation more cleaner, but it's still blocking. And if I want to do a business logic in between, I would be required to wait for invoke call first.
So what we should do if we don't want to blocking, we should run this particular execution in a separate thread. And we could do this now because the threads are cheaper now. Virtual threads is cheap now. So we can use executor submit, put inside it another thread executor invoke call. And here we can done with our business logic. And at the end we'll join, and that's work fine.
Okay, but still kind of ugly.
Yes, I can agree with this, but in the future, there are plans to add some structural concurrency approach here, and we will have the deadline for our thread executor, and also we will have, maybe we will have new methods submit that will return the stream of futures, and the stream is lazy populated, so you can do all your business logic here, and then can iterate like as usual stream and convert it to list. You even can use limit if you would like to have some first comes result.
So it's lazy and similar to streaming, but implemented through stream and futures. Well, interesting approach, but wait a bit. Our just recently, our hardware engineers say that they updated our sensors, and now our sensors supports streaming, so we don't have to kind of continuously ask the sensors. Sensors can just push every update, for example, from their side to our server, which of course improves performance significantly. So how is your Loom you're going to implement this type of approach? Are you going to be using, for example, observer pattern?
No observer pattern. I don't want to see it. It looks like functional programming. I want to stay in the usual imperative code. And for this kind of the problem, we have iterable. Iterable can iterate for the data that is passing for us from another source. And let's continue to use iterable for this.
Okay.
And how it can look like. So here we have our sensor client temperature, and in this way we can let so-called subscribe of the results. So the temperature we can, as this our sensor returns the iterable, we can iterate also for this temperature, and for every coming temperature we can create the sensor data. Furthermore, we can run for each our sensors this request in parallel. So we can in parallel iterate by each sensor and collect the temperature.
All right, but how are you gonna merge all of these results? So you start multiple iterators in parallel, but how you gonna collect?
Okay, I understand. Let's use for this any queue. But for example, particular linked blocking queue for here. And by the way, we have the limits for the number of this queue that should be implement the so-called back pressure.
Okay.
Are you happy with my solution?
Well, let's say it's gonna work, but you may imagine what's gonna happen once someone else would be required to apply some zipping or mapping or I don't know, other transformations. How about the code quality? It's just
let's wait for someone should implement some another particular library for this, and we will be happy.
Well, I know such library.
Yeah,
and it's called Reactive. This is actually a set of libraries. And first of all, I just want to remind that okay, folks sometimes like misunderstand the concept of reactive and sometimes mess it with observer or with async callbacks or set of callbacks like promise, which of course ugly and not always solve the problems. And I agree that Loom can solve just simple request response much better if this request response doesn't have to be merged with another set of request response. And you don't have to manipulate multiple non-blocking invocations and asynchronous calls, which has to be executed kind of simultaneously or almost simultaneously. With reactive, the real reactive, which is even researched in 1997 and so-called functional reactive animation or later on functional reactive programming, the solution for such problems started being nothing else than just functional programming combined with observer pattern and combined with iterable pattern. And all the things has already been implemented in great libraries like Project Reactor, RxJava, reactive extensions in all the platforms. And Akka Streams, of course, another good browser of Project Reactor and RxJava. And I just want to remind you, Andrew, that reactive programming is not about just functional pipelining. It's about programming on a data stream. That's why we need so many operators which helps solving day-to-day data stream processing problems. And moreover to that, reactive streams has already have this built-in back pressure mechanic, so you don't have to reinvent the wheel, and it's much more efficient than just simple batching. So, for example, implementing the streaming mechanism doesn't take us even lots of effort. What we have to do in order, for example, to implement streaming, we can just copy the previous method for polling, replace just temperature stream for sensors with temperature for sensors with temperature stream for sensors. And that's basically it. FlatMap works in the same way. It allows us merging multiple concurrent asynchronous calls or streams. And previously our streams was streams of a single element. Now this is infinite stream, which is equivalently fine for FlatMap. Nothing changes. And here we don't even have to use timeout. We can adjust it with retry or whatever other operator we want to use.
Okay, perfect. It was perfect. But could Loot Project Reactor can take some advantages from the Loom to improve itself?
I think so. Loom can be a great friend of reactive approach, and even more for Project Reactor itself. So, for example, we can achieve better structures with Loom and this reactive in general. So here we can leave the list user houses sensors as it was before.
Without converting to Flux.
Yeah, without conversion to Flux. It can remain just imperative and simple, and it can use Loom. Then, on the reactor side, we have great method from iterable. So we can wrap this call and convert it into Flux. And then we can easily convert our Flux back to iterable. So if you don't want to know about Project Reactor at all, and you want to isolate complex manipulation and sending of multiple requests to different endpoints in one method, you can easily do that. Here we go. Moreover, that's not it. There is much more to that. Better integration with blocking. So before we had to do this, and we had to use like bounded elastic, which is similar to cache thread pool. Now we can easily use virtual thread executor
to run the
blocking
code.
Call is not blocking anymore. Even more, here we have really complex structure since we have used flat map. And then in order to make a blocking call, we have to wrap in from callable, use subscribe on, use timeouts and other retries. Now this can just easily go away, and we can replace this code using this just simple map. And inside map, we can use block and call. And in order to make sure that block and call won't be blocking important threads, they can just publish our execution on the virtual thread executor. Easy. And I see much more future to integration with Loom. We can create much more simpler kind of generators or kind of wrappers around push API using Flux Create. Before we had to integrate with complex non-blocking and async demand or back pressure in order to make sure we are not overwhelming. Now this emitter.emit can just easily block the emitter thread, and this thread and this kind of emitter can easily be running on virtual thread, making sure that no important threads are blocking.
Cool.
So I would say that Loom is a friend of reactive. And to summarize, I would gonna say that Loom going to simplify apps at all. I agree. And for example, for scenarios like this one where we just have sequential calls to databases, to different endpoints, and we don't have to execute them in parallel and then combine and do complex manipulation. Well, in these scenarios, Loom shines really well. While in simple or not simple case where we have to do multiple calls, where we have to do streaming, where we have to manipulate with so many I/O endpoints, then reactive is going to be the best choice since it has great API, great set of operators, and tools for solving this type of problems. So I really suggest to use reactive where you have these scenarios and use Loom where you have this type of scenarios. With that, we can just say that Loom and reactive are friends, and thank you for your attention.
Thank you for your attention. So maybe we can ask some questions here. Answer some questions.
Yeah, let's have a look what we have in our chat. Oh, Mary, hello. Nice to see you.
Yeah, this is Andrii, yes.
Okay, questions. Question from Bogdan. What are the benefits of virtual threads executor over bounded scheduler bounded? So bounded elastic using just cache thread pool under the hood, while executor service.virtual thread per task executor is another kind of beast, which is creating virtual threads which are fibers, kind of coroutines, if you're familiar with Kotlin model.
Yes. And the more important difference that for Loom, authors rewrite the native API, and even near blocking calls now are not blocking. So IO blocking calls will be not blocked. So that's why it's take so long time to publish the version of Loom project.
Yeah, so this is the main difference. You may create millions of virtual threads, and it was kind of
non-blocking on-blocking operation.
Yeah, on-blocking operations. Before, like creating 1,000 or 5,000, depends on the machine type, of just normal kind of system threads was kind of great pain. And after some period of time, you might easily get out of memory exception.
Regarding the second question about Loom continuation primitive, it is not easy questions because the continuation class is not any public, and it is a private class only for JDK. And the authors of Loom don't want to provide access to this internal structure. So they propose to use different schedulers to run your business logic in such way here. So no way to access the internal API of Project Loom. You can read discussion about it in the mailing list of Loom project. So I think the next talk will be in 1 minute, and
thank you, folks, for joining us and for learning about Reactive and Loom.
Yes,
and
see
we wish you a great another day of Reactive Summit, and enjoy and learn.